students, in previous session we have seen ASME code means what, how we can utilize that ASME code on the basis of yield strength as well as ultimate tensile strength. Now we'll see the numerical on that. Now I have just written the given data, so just I'll read and we'll have to find out. In this numerical they have given the figure and the explanation I'll give from my side. So they have mentioned that shaft design on the basis of strength by using ASME code. That is the important one. Second thing, they have given the material of the shaft is 40C8 and it is having two values. One is SUT 650 Newton per mm square and another is SYT 380 Newton per mm square they have given. And they have asked determine the diameter by ASME code. So this is very important. While reading the numerical, as I told you, in the design process, you need to read carefully. If they have mentioned ASME code, we should not go for simple design. We'll have to go for only ASME code. Now, ASME code. And the diagram is given as like. I'll explain the diagram for you. They have mentioned that the pulley is situated on the shaft at a center. So, what it indicates? It has mentioned at a center, but they have mentioned the dimensions as like you can see there are the two bearings, bearing A, I would say, bearing B, which are act at both end, that is two different end. In this case, they have mentioned from the bearing A at a 200 mm distance pulley is situated, and for the bearing B it will be 250 mm distance. So according to that we have drawn. It is not center, but at somewhat distance from the bearing A as well as bearing B. Now they have suggested the pulley is situated, and pulley means it is having belt drive. So side view, in that they have given the pulley as having load condition, tension on tight side and slack side. The values are given. I hope it is visible that they have given P1 is equal to, I'll write here, P1 is equal to 1000 Newton and tension on slack side they have given 500 Newton. Earlier, whatever be the numerical we have solved, in that we have seen we need to calculate that, but here they have given no issue. And self weight of pulley they have mentioned 130 Newton, 130. I'll write here weight is equal to 130 Newton. Correct? So the diameter of pulley is 300 mm. It means its radius 150. So likewise structure is given. Now we'll go one by one as per the design process. Step number 1. We'll have to calculate maximum shear stress. Correct? So maximum shear stress on the basis of ASME code. So I'll write from ASME code. From ASME code I will have to calculate, that is, you can see what equation suggested, tau max is equal to 2.30 times SYT. So that I will have to calculate. So SYT they have given 380. So I'll get direct equation by considering SYT 114 Newton per mm square. Correct? This will be the first. And second equation in case of the ASME, that is 0.18 times SUT. Now SUT they have given how much? 650. So I'll multiply here 650. It will give me 117 Newton per mm square. Correct? These two values I have given, I have taken or I have calculated from the numerical. Now it is mentioned that very easy that we'll have to select the reduce the 70 we'll have to select 75 times as we have reduced the 25% from the value. So therefore my ASME coding maximum shear stress is equal to 0.75 times. Of course the shaft is keyed, keyway is present, into whichever be the minimum value of above. So minimum is, you can see 0.75, minimum 114, 114. So I'll calculate this, tau max is equal to, by multiplying this I'll get 85.5 Newton per mm square. So this will be the ASME code according to ASME. Correct? So this will be the shear stress will occur earlier if they have not mentioned ASME, I will have to calculate tau max is equal to 0.5 SYT by Fs, correct? Now here they have mentioned, that's why I have written tau max is equal to ASME code. So this is about the first step. Now we'll move toward the step number 2. As per the R sequence, step number 2, calculate torque. Calculate torque, empty value. And for that what we did the value of torque P is equal to 2 pi nt by 60. Now in this numerical they have not given the power. Second thing, they have not given the RPM, so we cannot use that equation because in that equation 2 unknowns are there. And as we know, if there is a 2 unknowns, we cannot calculate. So we'll skip that step. The next will be for calculating MT is equal to, we know P1 minus P2 into radius, which we have used. Now here P1 tension on tight side given, P2 tension on slack side given. So I will have to put, and radius of the pulley 300 mm, it means radius 150. So I'll write like 1000 minus 500 into 150, that is radius. So here I'll get the torque, and that torque value is around 75,000 Newton mm. Is that clear? So likewise we'll have to calculate the step number 2. Remember, wherever be the necessary as per the procedure, if there are 2 unknowns, we'll have to skip that step and we'll move forward. So we'll get empty, correct? Torsion. Then step number 3, to calculate bending moment. To calculate bending moment, as we know, see the structure carefully. Structure, what it indicate? The pulley is there, it means pulley is acting here. What kind of the loads are acting on pulley? P1, P2, W. So I'll write here total P is equal to P1, P2 plus W. So I'll write here step number 3 for calculating MP. I first know the total load. Total load. What is that? P1 plus P2 plus W. So P1 is 1000, P2 500, W 130, correct? 130. So by adding this, we'll have to get the total load acting on a structure, and that total load is around 1630 Newton, correct? So this will be the total load which is acting. I'll write here 1630 Newton. When this act, the bending moment will occur. So as I told you, for calculating bending moment, here A, here B. So reaction at A, reaction at B. Bearing reactions we need to consider because load is acting at in between that bearing. So I must calculate RA and RB. So here, as I told you, we'll have to take a movement with respect to A. If I consider movement with respect to A is 0, I will have to calculate minus, as I told you, the sign is moving in upward direction, minus RB into 250 plus 200, that is 450, correct? Minus, now it is moving downward, plus total load 1630, I'll write, correct? Force into perpendicular distance, which is equal to 0. No another force is there. Therefore, we'll get the value of RB. So just find out the value of RB from the equation. So 16 into 30, sorry, here force is 1630 into perpendicular distance, that is 200, which is equal to 0. Which is equal to 0 because this 200 is a distance that we need to consider. So RB minus RB into 450 plus 1630 into 200. So that will be the RB reaction force at B. It is, by calculating, it will get around 724.4 Newton. So I'll write 724.4 Newton. Now how to calculate then RA? Very simple. So RA plus RB is equal to, I'll write, what is that? RA plus RB, total force 1630. So we'll get the RA. It's your homework. RA you can calculate. Okay? So after calculating RA and RB, the bending moment will be, so for that you can see the bending moment we need to calculate, that is whichever will be the longest distance. I told you 200 or 250, it is 250. So that's why I will have to take RB. So RB into 250. So RB is how much? 724 into 250. So this bending moment you will get 181,111 Newton mm or 181 kilonewton we can say. So that will be the bending moment. So here we have calculated bending moment, torsional moment also. Now we'll use the final equation, that is tau max is equal to, this is hollow shaft? No. This is solid shaft? Yes. So tau max is equal to 16 by pi d cube. Now this is ASME code, square root of kb mb square plus kt mt square. Now kb and kt they have given, so we have not written here. If they have not given, we'll have to take 1. Always remember, if they have not given, we'll have to take 1. Now in this equation I forgot to give you kb and kt, they have mentioned 2.5. kb and kt are 2.5. So we'll have to take 16. Tau max is how much? 85.5. 16 by pi d cube square root of kb 2.5 into mb 181 into 10 raised to 3, I'll write bracket square, plus kt 2.5 into mt 75,000 bracket square. So after calculating, unknown is only d, so just try to calculate with me. And the diameter of the shaft for this case 30.7. So as I told you, the diameter of shaft will nearly equal to 35 mm is suitable for designing or for the given statement conditions. So I hope you understood this. This will be the stepwise procedure to solve the numerical. While reading the numerical, you must get clear that whether it is ASME code, whether it is hollow shaft, whether it is solid shaft, and according to that we'll have to follow the same step which I had explained you in the previous session. Clear? So practice it, and if any query, let me know. Thank you.